Bismillah, alhamdulillah, salatu wassalamu ala rasulillah. In this class, inshallah, we will practice by solving more recitation exercises from sections 1.7 and 1.8. Let's remember quickly what do we have in these sections. In section 1.7, we have learned how to solve linear and nonlinear equations, linear and nonlinear inequalities, not equations. The main ideas that you need to use in 1.7 are the rules of inequalities, that the two inequalities are equivalent if you add or subtract or multiply by a positive number. But if you multiply by negative, you need to reverse the sign of the inequality. The guidelines for solving nonlinear equations are here. Move all terms to one side, factor, find the intervals. To find the intervals, you need to find the zeros. To factor, you need to write, if you have fractions, as a single fraction. Then you will make a table of signs, positive, negative, and then solve. In 1.8, these are the main ideas, three rules that you need to apply when you solve any question from 1.8. Solving absolute value equations. To solve absolute value equations, try to isolate the absolute value and then use this property. When you have inequality involving absolute value, remember this: the absolute value of any algebraic expression is less than a positive number if this algebraic expression is between negative and positive that number. If it is greater than, you will use this rule. Let's start by 1.7. And let's think loudly about solving this. In your notes, please, in your notebook, please try to solve this exercise. And think loudly, no problem. We need to hear from you. It is better to classify the inequality. Ask yourself, which type is this inequality?
Fraction.
It is linear or nonlinear? Is it absolute value? So what is it? Nonlinear. How to solve nonlinear?
Make it one fraction, one single fraction.
Remember, to solve nonlinear inequalities, you need to move all terms to one side, then factor, then find the intervals. This is the algorithm that I told you to follow always. So now are all the terms on one side, and you have the right hand side equals to 0? Good. So step number 1 is done. So then what you will do? Do you have all the fractions as a single fraction? Do you have all of them over the same common denominator? Yes, we have only one single fraction here. So what you will do then? Factor. This is step number 1 in this case, for this exercise. Factor. What you can do for the numerator? For the numerator, not the denominator. For this one, what we can do to factor?
Make 8 power 4 multiplied by power 2.
Are you kidding?
It's factored.
It is already factored. It is x minus 8 multiplied by x minus 8 multiplied by x minus 8. How many times? 8 times. So it is not practical to write it like 8 times. So just write it x minus 8 all to the power 8. This is what we said about yesterday. Don't destroy it if you have it in the nice form. Now what we will do, we will factor the denominator. So what is it? X plus 3 times x plus 4. All will be less than or equal what? 0. Now what we will do? We will find what? The zeros. What are the zeros? Oh, I forget, all to the power 8. Don't forget that. So what are the zeros, guys? 8. We have 8 in the denominator, and -3 and negative. These are the zeros of the 3 factors that we have. If we can see 3 factors, in fact, they are, in fact, here 10 factors. 8 is repeated, of course, 8 times. Now, next, what we will do? Check what? Let's go back to the guidelines. What is that? Find the intervals. To find the intervals, we need to find the zeros. We did find the zeros, so now we will go to find the intervals. So we will go to the numbers line,
Real number rise.
the real numbers line or the real line. Here it is. This is negative infinity. This is infinity. Okay, let's go back. This is infinity. Now, what are my zeros? I should them here, write them here in order. Which one is the first one? Negative 4, negative 3, and then 8. Open or closed? All of them, they are supposed to be all closed. But since negative 3 and negative 4 are in the denominator, they will be what? They will be open. The only one that will be closed is what? 8. Excellent. Now what we will do? We will write the factors here. The first factor is x minus 8. You know for x minus 8, it is 0 where? It is 0 here.
Yes.
After that, it is positive. Before that, it will be. But this is not x minus 8. This is x minus 8 to the power what?
8.
So it will be what?
Positive.
Always positive. Then the second factor is x plus 3. X plus 3 is 0 here at negative 3. After that, it will be positive. Before that, it will be negative because the coefficient of x is positive. Now, the last factor is x plus 4. Again, it is 0 here. After that, it will be positive. Before it will be negative. In the bottom line here, we will write the quotient. The product of sign, the quotient of signs, this one here. So what we will have? Positive, negative, negative will be what? Positive, negative, positive, positive. What do we want? We want this to be what? Negative or 0. So the solution set is open negative 4, open negative 3. The open interval negative 4 and negative 3. But this is not true, by the way, Shabab. There is something missing. What about 8? We closed it. Do you remember? It should be included. So what we should do, say here, from negative 4 to 8? Union what?
8.
Only 1 point, which is 8. So it is a singleton set. It is 8. A single and a set with only 1 element. So we will write it inside 2 braces like this. So we mean negative 4 to negative 3, the interval, all the numbers between negative 4 and negative 3, and also 8. Excellent. Because 8 is the one that will make the expression on the left equals to 0. Let's go to the next exercise. How to solve this? Linear, non-linear, absolute value, what is it? Always it is important to know what to do. So since it is non-linear, what we will do? Move all the terms to one side. So it will be what? Usually we make the right hand side equal to 0. And the left hand side is the one that is non-zero. So let's move these. Here we are. Now it was better, by the way, to move only this term if you want and make it less than 0. You can do that. Why not? Now, can I multiply by the LCD?
Yes. No.
Who said yes?
No.
No, you cannot, because in the LCD here we have x plus 1. We don't know is it positive or negative. So do not multiply by the LCD. So what to do? Multiply by 2 only. So what will happen if you multiply by 2? You can multiply by 2. Why not? So we multiply by 2. Then what? I need to hear here a single word, a single fraction. We need to write the left hand side as a single fraction. We need to bring them over the same common denominator. What is it? 2 multiplied by x plus 1. Now, what we need to do for this denominator to be the same as this, it needs to be multiplied by x plus 1, right? We need to multiply it by x plus 1 minus 5. 5, it has x plus 1 in its denominator. It needs to be multiplied by 2. Minus 4. 4, in fact, it needs to be multiplied by both, by 2 and by x plus 1. All greater than or equal 0. Now, what we need to do? Simplify the numerator. It will be x squared plus x minus 10 minus 8x minus 8, right? Over. Can we multiply both sides by 2?
Yes, we can.
Done. So it will be 2 cancelled with 2, and 0 by 2 is 0. It's okay if you keep it there, no problem, because it will not affect the zeros, it will not affect the sign. If x plus 1 is positive, 2 multiplied by x plus 1 will be positive. If x plus 1 is 0, also 2 multiplied by x plus 1 will be 0 at the same number. Good. Next, we will have x squared minus 7x minus 18. We will combine like terms greater than or equal 0. Next, what we will do next? We need to factor. So let's factor. Let's factor here. So it will be what? X minus 9 multiplied by x plus. Make sure that you are factoring in the right way. Don't go to the next step. So what are the zeros now?
9.
We will find the zeros now. 9, -2, and negative. Now go to the numbers line, put them in the right order. We will start with -2, then -1, then all of them are closed except why? Because it is in the denominator. Excellent. Now, what are my factors? X minus 9, x plus 2, x plus
1.
Now x minus 9 will be 0 here. After that, it will be positive. Before that, it will be negative. X plus 2, it will be 0 here. After that, positive. Before that, negative. X plus 1 is 0 here. It will be after that positive. Before that, negative. Now let's do the quotient. It will be a what? Negative, positive, negative, positive. What we want? We want it to be greater than or equal 0. So we want to take the positive part. So the solution set will be closed -2, open -1, union, closed 9, open infinity. Right? What is the problem? Why it is not right? Let's check. We cannot check. It is there. Can you see it? Here it is. Okay. It is. It is. If you look at it, -2 and -1, 9 and. This is how to build your confidence. You are sure about your steps, your methods. What about this question? This is a good question. It is in 1.7. This is 1.7 recitation, but it can be solved with the methods of 1.8. Also, it can be solved as 1.7 problem. Again, good idea. Good idea. So what we will do?
We'll have 4 less than x squared.
X, we will write it as x squared less than or equals 9 greater than 4. What we did, we add 4 for the 3 sides. Then, can we do that with inequalities?
No, we can't have to do.
You have to be careful, by the way. If it is normal, ya shabab, if it's okay always, we will mention it here. Why we didn't mention it in the rules? If you take, what will happen if you square both sides, if you take the square root of both sides?
Positive and
We will not hide it from you if it is always true. Why we didn't mention it here? Because it is, you have to be careful when you do such things. Let me show you something. Let me show you something. For example, 4, let's take 4. We talked about 4. 4 and let me erase this here because we need to work on this slide. 4 is less than 9, clear, right? Take the square root of both sides. 2 is less than, it works, right? But if you have -4 less than 9, it is true that -4, it is less than 9. Now take the square root of both sides. This is not real. So this is 3, but this is of course 2i. We don't know, it is not real. We will say it is not real. We cannot compare between real numbers and complex numbers. So when we take the square root, both must be positive, not the same sign. If they are negative, you cannot take the square root. We are talking about, guys, we are talking about intervals. The intervals are on the real numbers line. So we are talking about real numbers. When we work on the real numbers line, we are talking about real numbers. So you cannot. Not only that, only squaring both sides, it is dangerous when you have inequalities. Look, -3 is less than -2, right? Right? Square both sides. What you will have?
9 less than 4.
Great. It is not true.
Yes.
So you should reverse. So it is, in fact, you have to be very careful when you deal with inequalities, when you square both sides, raising both sides to powers. So be careful. And you have to consider the truth of the statement in this case. Now, let's see if there is a problem in our case or not.
Is there a way to solve it?
Without, yes, we can. Let's start with the idea, because this is came to your mind. You said add 4 for both sides. So this will be 9. This will be what? 4. We can divide by what?
No,
Why you change your mind? You are okay. It's okay. Now, this is positive. This is positive. This is positive. If it is x, by the way, you cannot do that. Do you know? You cannot take the square root of all the 3 sides, unless, of course, if you are sure that x is positive. And x is positive here, by the way. Why x is positive? It is between 4 and 9, so it is positive. You can take the square root. Here, for sure, it is x squared. Okay? So now you can take the square root of both sides. So you will have here what? 2 less than? No way. Yes, please, ya Shabab. You still talking about this after these many weeks. This is 3. So in fact, what we did, we take the square root of both sides. When you take the square root of both sides, you have absolute value in the middle. What we will do next? X will be less than or equals positive or -3, greater than or equals positive or -2, right? Yes, are you sure?
No, it's really hard to determine.
Please put yourself in the place of x. What you will do? You will get crazy. How can I be, how do you want me to be less than positive or -3 at the same time? And at the same time greater than or equal to negative and positive 2. This is make no sense. Yes, yes, it will get lost, of course. So this is not true at all. This is a common mistake, Shabab. Please avoid doing this.
We can say once,
What we should do?
separate it and solve.
Separate it. So in fact, this can be solved like this. The absolute value of x is less than or equals 3, and not or. The absolute value of x greater than 2. This is now 2 inequalities, and they are easy to be solved. This is x between 3 and negative, right? And here we have what? X greater than 2 or x less than -2. You remember the rules?
Yes.
Now go and draw the numbers line. -3 and 3, here we are. Let me put it a little bit here. Closed,
Yes.
and here we are. This is the solution set of this branch. For the second part, x less than -2, this is -2, this is 2. So this is open, -2. This is open, greater than 2. Now what we want and. We have here what? And.
Intersection.
So the intersection. So the intersection when they are overlapping each other, which will be what? Closed, -3, open, -2, open 2, closed. Which answer is the right answer? It is
By
D.
the way, can't we make reverse just 2 less than x and reverse the sign?
What is that? I didn't get your point.
And
Where? In which step?
Yes, in this step.
In the
just
second
reverse-
step?
No,
Here?
yes,
Okay.
this is the first solution. Then the second solution, just reverse the sign. And
This is
make
what I
it-
told you yesterday. This is what I told you. When we have x greater than 2, can we write it as x greater than 2, less than -2? We can write it like this? No, we cannot. So what you are saying here, I know what you are saying. X less than or equals 3 greater than 2. This is 1, and or what or what? Or x what? Less than -2, greater than or equals -3. So in fact, here, this is the same mistake that I told you about it here. We should deal with it as less than of this, and we have or in that case, and we have less than. It can be, how it can be, please, Yani, if you want to say that. It might work for this specific kind of problems, but it is not in general. What you need to do, it is better to separate it, to avoid any errors. By the way, no need to use the absolute value here for such problem. You can solve it with the ideas of 1.7. How can we do that? we have x squared minus 4 less than or equals 5 greater than 0. What we will do? We will separate from the beginning. So we will say that this is x squared minus 4 less than or equals 5 and x squared minus 4 greater than 0. So what we will have here now, this is quadratic inequality. It will be x squared minus 9 less than or equal 0 and x squared minus 4. Let me write it like this, greater than 0. Now we will factor. You remember the ideas of this section. Then here also x minus 2 times x plus 2 greater than 0. Then what? You make a table here. You have here negative 3 and here 3, and you will make a table here. You have here negative 2 and what? You will get here, this is closed, this is closed. You will get it like this. Here you will get it open. This is open, and you will have the same solution set. No need for the absolute value if you are not happy with it. But of course, you cannot avoid it in many questions. Let's solve the one I think we mentioned with you at the end of the previous class how to solve it. We solve it?
We did it.
So what was the idea? Could you remind him about it? How do we solve?
We will solve for x and build the
Solve this one for what?
for x.
For x. Let's
Build
solve
and
it for
build
x.
for same,
So what we will have from here? From this one, what we have?
two cases.
X minus 5. It will be x minus 5 less than a half and greater than negative a half. We can solve this easily. Add 5 for both sides. It is less than what? A half plus 5 greater than negative a half plus 5. So this means that x is less than what? 11 over 2 greater than 9 over 2, right?
Yes. No, it's
It
positive.
is 2 to 5, 10 minus 1 is 9. Now this is our x. What we will do? He said that this inequality, it is equivalent to this inequality. So what?
We build it.
What we have when we have equivalent inequalities? We can go from one to another by adding, multiplying, dividing. They have the same solution set because they are equivalent. So what we can do here?
Build it. Multiply by 2 and
Why by 2? Why not by 3, by 4?
because it's the same.
Because the x here is multiplied by what?
2.
So we are building now our inequality. So we multiply both sides by 2. What we will get? 11 greater than 9, right? Then we will subtract what? 3. So it will be 2x minus 3, and this will be 11 minus 3, 8, and this will be. Now compare between this and this. Compare between them. 2x to x. So what is this 6? It is what? It is m. What is 8?
N.
It is n. Easy. There is another way. Do you thought about it? Yes. How? You can solve this. We solved the first one. Let's solve the second one. To solve the second one, what you will do? It will be 2x less than n plus 3 greater than n plus 3. Then divide by what?
By 2.
By 2. Now we solve both. What we can do after that? Now we have this one, we have this one. Compare between these two. What you can conclude?
M plus 3 equal to 9. N plus 3 equal to 9.
So compare between this one and this one.
The denominator is the same.
M plus 3 over 2 will be 9 over 2, and n plus 3 will be what? 11 over 2. But this is not the, better than the previous one. So m plus 3 will be 9, and of course n plus 3 will be equals to 11. From here m is 6, and from here n is what? Is 8. Because they are equivalent, we can do that, of course. As you know, now for this, we have time. Yes, we have time for this one. This is a good question because it is 1.7 and 1.8 together in one question. How to solve it? Read it. So if A is the solution set of this and B is the solution set of this, then what is A intersection B? What we will do? One by one. We will find what? A. Then we will find B, then we will find the intersection. This is the plan. Who can find A, Shabab?
First of all, factor it.
Factor it. It is ready. The right hand side is 0. So just factor. So what we will have?
X plus 7 squared.
X plus 7 all squared. It is perfect square. Over. This is minus.
Plus 4 minus 3.
X plus 4 times x minus 3. So what are the zeros?
Negative 7.
Let's go. Write them here down. The zeros of these factors are negative 7, negative 4, and positive 3. Write them here in order. We will start with negative 7, then negative 4, then 3. Which one is closed? Negative 7. These are open. They are in the denominator. And why negative 7 is closed? Because here we have or equal. If we don't have or equal, it will be also what? Open. Excellent. Now we will write our factors. The first factor is x plus 7 all squared. Positive always. Don't worry about it. X plus 4, it will be 0 here. After that, positive. Before that, be careful, Shabab. If the coefficient of x is negative, you should reverse. It will be the opposite. Negative, negative, then positive, positive. X minus 3, positive here, negative otherwise. Now, in the bottom line, we will find the product, which will be what? Positive, positive, negative, positive. Is that right? Okay. So, what we want it to be? We want this to be negative. Here we are. So because here it means negative. So the solution or A will be what? Open negative 4, open 3, union negative 7 only. The point negative 7 because it will be 0 there. So this is A. Excellent. So I'd like to write negative 7 at the beginning. Do you mind? Because it is the smaller one. So it is better to have it in this order. Negative 4 union negative 3. 3, not negative 3. I'm thinking about the answer, by the way. Now this is A. What about B? How to find B? Do you remember what we did?
Yes.
Separation, of course. It is better to be normally and formally solved by separation. Let's keep this here and go to solve this one. So it will be what? X greater than or equal 7 and X greater than or equals 3. Is that right? This is less than. X is less than or equal 7 and the absolute value, not X. The absolute value of X is less than 7 and greater than 3. From here, we will have X between 7 and negative. And here, we will have X and we will have here X greater than or equals 3 or X less than or equals negative 3. Let's go to the numbers line and do the calculation. Negative 7, 7. This is closed. And we have between negative 7 and 7. Then we have negative 3, and here we have 3. This is open or closed? Closed, both. And here we are. So where is what is B? Let me use another color. Let's use this. So this is B. B is what? Closed, negative 7, closed, negative 3, union, closed 3 and 7, right?
Yes.
Now, who remind us what was A? What was A? A, it was negative 7 alone as a set, negative 7 union, negative 4 up to where? Up to 3, right?
Yes.
Now, what is the intersection of these two?
Negative 7.
It is better to draw them on the same numbers line to find this surely. So negative 7 to 7, and here negative 3, and here 3. We have negative 4, so let me write also negative 4 here. Here we are. So we have this. I will use the red color for what? Let me use the red color for A. And here we are. Okay. And I will use the same color for B. Not to negative 3. You're right. So let's correct this. It is from negative 4 to 3. Okay.
Yes.
Now for 3, it is closed. Let me use this color. So this is closed. Now -7 is closed, red and what? And blue here. So it will be -7 included up to where? Up to -3, right?
Yes.
Then closed 3 up to where? 7 closed. Now what we want?
The intersection.
The intersection. So we will take -7. Are we going to take -7?
-4,
-7 only.
You can take
-7, is it included?
Yes.
Is it in both?
Yes.
Yes, here it is. So -7, this is the first one that we will take. Alone. From -7 to -4, there is nothing in common. There is nothing in the intersection. -4, is it in the intersection?
No.
So we will start from here, but it is open at -4. Then is the -3 here in both?
Yes.
Yes. Up to where? Up to 3. Is 3 there? 3 is above, but not below. It is in B, but not in A. So up to 3 what? Open, right? Is that right?
No. Between -3 and 3, there's no common.
No common. So we will stop here, -3. Closed, then union from 3 up to where?
7.
3 to 7.
That's it.
That's it. There is nothing in common after -3. Okay, the answer is what? The answer is D. Okay, Shabab, I think that's it. We need now to go to start quiz number 4.